Okay, so we're going to just recap a bit of calculus, guys. So that's in chapter 14 and 15. So if we can just open at chapter 14 and we'll just flip through there. So in chapter 14, we start by talking about rate of change, okay? And so that's where we introduce you guys to the average rate of change, okay? Slope between 2 points, and instantaneous rate of change, slope at a point. So if you have a graph, right, average rate of change between these 2 points is the slope between them. Instantaneous rate of change is going to be the slope at... Brad, you can just wait outside, thanks. Yep. Is it just the slope at a particular point? How steep is it at that exact point in time? Okay. Moving on, we've got 14. So in 14b, that's what we're talking about. 14c, we introduce you to limits, all right? So a limit is just basically as x approaches some particular value. It's a little bit like function notation. And then we get into the derivative function and first principles, don't we? Okay, so this formula here, f dash of x, is the limit as h approaches 0 of f of x plus h, take f of x on top of h. That is the first function for the derivative. Okay, what is the derivative? So remember, and we can introduce you to that. We have y equals f of x, that's our function. And then we have dy on dx equals f dash of x. That is our derivative function. Okay, you put an x value in here, it's going to tell you the y coordinate. You put an x value in here, it's going to tell you how steep the function is on any value of x. Okay, so then we get into chapter 15, and in 15a we talk about simple differentiation. Okay, so if we have x to the n, then the derivative is nx to the n take 1. And we're just applying that rule there. We don't have to do this process every time unless it says using first principles. We can just differentiate using simple differentiation. Okay, 15b, we talk about tangents and normals. And we looked at 3 processes for finding the equation of a tangent and a normal. What is a tangent? On a line that is parallel to the curve at a point. So in calculus, we're finding how steep is it there, and then we're saying, so what is the line that goes through that point, touches at that point? The normal, that's the line that's perpendicular to it, meets at 90 degrees. Okay, so that's in 15b, lots of good questions in there. Then in 15c, we talked about increasing, decreasing. So the link being, right, if we have some function, let's just go for a simple one, x squared, the derivative function is 2x, all right? And so this is the slope function. It tells us the slope, right? And if we draw the sign diagram of this function, okay, of the derivative function, we've got 0 and it's going from negative to positive. And so what that tells us is it has, the slope is negative and then the slope is positive. Remember, this is the slope function. Negative and then positive. And how is that reflected in this function? What does it tell us about this function? Well, let's graph this one. Let's make a link. If we graph the function x squared, this is what it looks like. And what we can see is it has negative slope until we get to 0, and then it has positive slope after 0. So the sign diagram of the first derivative tells us when it's decreasing, okay, it's decreasing there, and then when it's increasing there. All right, so that's in 15c. And then in 15d, we took that a bit further because in 15d we figure out, well, that means there's a local minimum because it's decreasing and then increasing. And so we're using calculus methods to find local mins and max. And then in 15e we get into kinematics. Okay, so displacement, velocity, and acceleration. So S of t being the displacement function. V of t is the velocity function, is the derivative of displacement. All right, what is velocity? But rate of change of displacement, and then acceleration, rate of change of velocity. Cool, that's a good calculus recap there. Good question?